Good morning, girls. How are you? Okay, today we are just going to be doing some extra examples about lesson 16.3. Just the homework and classwork that I left for you on Thursday, just to make sure that you understand it carefully. And then you will be jumping lesson 16.4 because lesson 16.4 is again cancelled. And then we are going right away to revise module 16. And then from tomorrow, inshallah, we are starting module 17. Okay, what are the questions that we are going to be solving today? In this video, we are going to be solving page 808 till I think page 811. From page 808 till 811. And we are solving question 3, 5, 8, 9, and 11 together, just to make sure that you get the hang of the idea carefully. Okay, let's start with question 3. Okay, in question 3, the headline of the question, let me open the online student edition instead. I don't want you to see the answers right away. Okay, so the question is, draw the image of each figure under the given transformation. He is going to be giving you a transformation and we need to draw the image. Then describe the transformation in words. Okay, just as a reminder, we said how many transformations we have. We said that we have 4 transformations. Translation, and it was a rigid motion. Rigid because it keeps the body having the same size. The image and the pre-image are having the same size. And we said that we have as well reflection, in which you are mirroring 2 objects from here to here, for example. And we said again that this is again an example of rigid motion, because again the size of the pre-image and image are the same. What about rotation? Again, it's a rigid motion in which you rotate clockwise and counterclockwise, but it's again a rigid motion. And the only non-rigid motion was, yes, the dilation, or in which we can call it as stretching or shrinking or compression. We can write this here as a note, just to make sure that it will never be missed. Translation, in which you will always find its coordinate notation x plus or minus a, y plus or minus b. This is always a rigid motion, always. Okay, this is number 1. Number 2, reflection. Reflection, in which you will find that x and y will be like y negative x, or like negative x and y, something like this. Something like this. I think this is x and negative y as it is. And you keep the x and y in the same place, but you add a negative size. You add a negative sign. This is always a rigid motion as well. This is always a rigid motion as well. What about if I am talking about rotation? Rotation have a lot of coordinate notation rules, so I'm not going to write a specific one, but it's always a rigid motion as well. And then the 4th one, which is the dilation, that we can divide it into 2 parts, as we said, either stretch or shrink or compression. Take care, the word shrink can be written as compression as well. The same word, the same idea, the same meaning. Both of them come in this way. X and y will be either a x or b y, or in which a and b are bigger than 1. If it's bigger than 1 and it's multiplied by x or y or one of them, so it's a stretch. What about shrink? You will find that a and b are less than 1, like a decimal or a fraction. If you find this idea, all of this are changing size, so this is a non-rigid motion. Okay, This is a very, very important note. Please, if you can, write it again on a sticky note as a whole, because all of this is important. Okay. Now let's get to our examples today, beginning by question 3. Okay, in question 3, this is the question. The rule given is x and y will be x and 1/3y. Before we draw the image and before we identify what is the kind of this object or this transformation, and is it a rigid or non-rigid, can you try just by seeing this rule in the coordinate notation and seeing these notes that we wrote, can you tell me, is it similar to the translation? Is it x plus or minus? No, so this is not a translation. Is there a negative sign? Is it including negative sign? It's not including negative sign. So it's not reflection nor rotation. By the way, the rotation as well include a negative sign. Yeah, if you write the coordinate notation of rotation, it will be similar a little bit to the reflection just by flipping x and y together. But it again include a negative sign. So is there a negative sign here? There is no negative sign, so it's not reflection nor rotation, but there is a number multiplied by x or y, as in here. There is no number multiplied by x, but it's multiplied by y. So this is a what? This is a dilation. Now let's see which kind of dilation. The number multiplied, is it bigger than or less than 1? It's less than 1, it's 1/3. So I am sure that this is going to be a shrinking or compression, and this is a non-rigid motion, right? Okay, how to solve it? I have to find the coordinates of the 3 points so that I can find the new coordinates and then graph my image. Okay, I have 3 points. We have F, we have E, we have D. And the rule given is x and y equal to x and 1/3y. Okay, so let's begin in page 808, question 3. First of all, I have to find the what? First of all, I have to find my coordinates so that I can start to draw my image. We have how many points? We have 3 points since this is a triangle. I have F, I have E, and I have D. And now let's find the points. Extract the coordinates. Yes, what about point F? F is what? F is -3 and -3. -3 and -3. What about E? Again, +3 this time because it's in the positive side. So 3 and -3. What about point D? 1 and 3. So this is my coordinates. Now what should I do? I have to multiply it, or I have to apply this rule on it. In this rule, my x stay as it is, and y I have to multiply it by 1/3. So x as it is, and then -3 by 3, it's going to be a -1. What about E? 3 as it is, and then this is going to be a -1, and here 1 as it is, and this is going to be a 1. So this is my new points. This is F prime, this is E prime, and this is D prime. And then you are going to take these 3 points and grab them in the new place, and this is what you are going to find. This is going to be my points. After you've drawn the image, what do you think? What is this image? What is the transformation happening here? It's very obvious that it is shrinking or compression. Your triangle have been shrunk, right? But is it a vertical or a horizontal shrinking? The horizontal, if we go to see the horizontal side of my triangle, actually it is the same as the pre-image. From here till here, and here from here till here. Now, if you are looking at the vertical position of my triangle, then the pre-image was vertically like this, and then it shrunk. So actually this is a vertical, as you can see here, vertical compression or shrinking by a factor of 1/3. And actually this is coming from the rule right away. In the rule, x is as it is, just I multiplied y by 1/3. So right away I can know that this is a vertical compression by a factor of 1/3. And we can add here that this is a rigid or non-rigid motion. We can add here that this is a non-rigid motion. And vertical compression by 1/3. Okay? Okay. Next we have question 5 in the next page. In question 5, use coordinate notation to write the rule. This time he is giving you the points of image and pre-image, and you are required to write the rule itself that maps each pre-image to its image. Then identify the transformation and confirm that it preserves length and angle measure. You remember I have to use the distance formula and the angles. Okay, before we do anything, what do you think? This is a rigid or non-rigid motion? Just see your figure. It's very obvious that it's rigid. It have the same size. It's very obvious that this is a rigid motion, and I have to identify this using the distance formula and angles. Okay, let's put the points that we have in here and start finding a rule for them. I have A as -4 and 4, and it became A prime 4 and 4. We have B -1 and 2, and it became 2 and 1 as B prime. We have C -4 and 1, and it became C prime as 1 and 4. Okay, let's start thinking about X and Y. We have 4 in here, and it became here. We have 2 as Y, it became as X. We have 1 as Y, and it became as X. And we are pretty sure that in this transformation, which is X and Y, the Y come instead of X. The Y, which is 1, 2, 4, came instead of X. That's why I put it here in the place of X. Let's think about the other value. What about -4? It became a 4. What about -1? It became a 1. What's happening? I'm changing the sign as if I'm multiplying by -1. -4, it became a 4. We can say that the X value became the Y value, just I added a what? I added a negative sign. So this is my new rule. So X and Y became Y and -X. We found the rule. To find what's happening as a transformation, since we don't know the coordinate till now, by the end of module 17, inshallah, you will be knowing the coordinate notation of each transformation. You will be knowing this and you will be memorizing them, that whenever I see this coordinate notation, what transformation, whatever transformation is happening, you will be knowing this by heart, inshallah. But for now, we can actually understand this using our image and pre-image. Where is the pre-image? The black one, this one. And this is my pre-image. This is the image, sorry. Now what's happening? Is it translation? Of course it's not translation. Is it reflection? It's not reflection. Is it dilation? It's not dilation. So I am left with rotation. Yani I can say it's rotation. Rotation, how many degrees? Before rotation, how many degrees? Rotation clockwise or counter? Is it clockwise? We started here, take care, and we came here. I am rotating in this way. So this is a what? It's a clockwise. Okay. After understanding that it's a clockwise, I have to understand, or I have to say how many degree the rotation is. And we said that if I'm moving 1 quad, this is 90 degree. If I'm moving 2, it's a 180. If I'm moving 3, it's a 270. And the 360 actually never happens, because 360 means you didn't do anything. Okay, anyway, we are going to check one point and see how many quads did it move. Let's think about A, for example. A was in quad 2, and then it rotated to quad 1. But I rotated how many quads? 1 quad. But I can say that this is actually a what? Rotation 90 degree clockwise. The word around the origin, we will learn it inshallah in module 17. What about around the origin, around a certain line, these things? Just for now, I am very, very satisfied. If you tell me it's a rotation 90 degree clockwise, this will be very, very satisfaction for me. So here we can say, after seeing the image, we can say that what transformation is happening here, it's a rotation 90 degree clockwise. And this is known by seeing the image itself. Now let's go to the part of preserving length and angle measure. To understand if it preserves length and angle measure, I have to use, first of all, for the length, I have to use the distance formula, which was a huge square root x2 minus x1 all square plus y2 minus y1 all square. We have how many lines? I have 3 lines. Let's start by AB, for example. Finding the distance of AB. Let's find the distance of AB, and this is my points, AB. So, huge square root, and then x2 minus x1. So, negative 1 minus minus 4. All square plus y2 minus y1, which is a 2 minus 4 all square. Under the calculator, under the square root and using the calculator, you will find that your answer is square root of 13. And since I'm pretty sure that this is rotation, so this is a this is a rigid motion, yeah, I can say that right away this is A prime, B prime as well. I don't need to really measure it again. It's already understood since this is a rigid motion. Okay, for BC. BC. So x2 minus x1. So negative 4 minus negative 1 all square plus y2 minus y1 all square, which is a 1 minus 2 all square. And you will find your answer to be square root of 10, which is going to be B prime, C prime right away. What about the last one, which is AC? AC, I'm looking at the first point and the last point. So negative 4 minus minus 4 all square plus y2 minus y1, which is a 1 minus 4 all square. Using the calculator, you will find your answer is 3, which is the same as A prime, C prime. And then using your protractor, as we said, in which you are going to get your protractor and put, I need to measure the 3 angles. Starting with angle C, for example, I'm going to put the center on the center, which is C. The center of the protractor on C, and then the line of the protractor on one of the 2 lines that are around the angle. But for example, if I put it at BC, so I'm going to measure my angle from here. But my protractor is going to be in here, and then I'll start reading from here, from this 0, since this is the line, until I hit this line. If this is a short line for you, you can just extend it so that you can measure the reading carefully. And then for B, you are going to do the same thing, just instead of the center being here, it's going to be in here, and then my line will be in here. So I'm going to be reading from this 0 and then go up until I read the measure. Of course, in the previous video, I explained in details how to use the protractor. So if you still have a problem, you can go back to the previous video and see the online example we did together. Okay, so for now, I can put the angles right away. Measure angle A will be 56 degrees, which is the same as measure angle A prime. Measure angle B equal about 52 degrees, which is the same as B prime. And measure angle C, you can either measure it or use the 180 degree rule, which is 72 degrees, the same as measure angle C prime. So I am pretty sure that this is a rigid motion. Preserve length and angles. Okay. Okay, going to the second example, which is example 8. Not the second, this is the third. Okay, example 8. What's required in example 8? use coordinate notation to write the rule that maps each pre-image to its image, then confirm that the transformation is a non-rigid motion. Non-rigid, so I'm talking about what? It should be dilation. I can predict that my rule is going to be including a multiplication by a certain factor. Okay, in question 8, we have the points f, -1 and 1. It became -2 and 1. We have the points g, 1 and -1, and it became 2 and -1. We have the point h, it was -2 and -2, and it became h prime as -4 and -2. So this is my 3 points. Okay, let's try to investigate. Since this is a non-rigid motion, so I'm going to be investigating which of the x and y. Take care, they are not going to be flipped. No, each one in its position, just one of them is multiplied by something. Let's investigate. -1 became -2, but 1 remain as it is. -1 remain as it is. -2 remain as it is. Yani, in other words, I can say that y didn't change. Is not multiplied by anything. It is y as it is. The x is the one that had the multiplication. -1 became -2. To know the multiplication, girls, I have to divide the image by the pre-image. The image by the pre-image. You know, I'm going to tell myself -2 by -1 is 2. So this is the factor. This is called the scale factor. It's a 2x right away. X and y became 2x and y. Okay, and then to make sure that it is non-rigid motion, what I'm going to do, I'm going to start finding fg and fg prime so that I can make sure that they are not equal, so I can tell him that this is a non-rigid motion. Using distance formula, fg will be a square root of x2 minus x1, which is a 1 minus -1 all square, plus y2 minus y1, which is a -1 minus 1 all square. The answer will be square root of 8. Let's find the same thing for fg prime here. 2 minus -2 all square plus y2 minus y1 all square, which is a -1 minus 1 all square. The answer will be square root of 20, non-equal. So this is, I'm going to tell him fg is not equal to fg prime, so it's a non-rigid motion. Okay, understood? Going to question 9. Question 9 is an extra example that I didn't give you as a classwork. So let's try to read it. It's a long one, but actually it's very easy. A mineralogist is studying a quartz crystal. She used a computer program to draw a side view of the crystal as shown. This is a side view of whatever. This is something. And then she decides to make the drawing 50% wider. Wider mean that what's happening? What transformation is happening? This is stretching. Wider, it's going to be bigger. So wider mean it's going to be, now we are in question 9. Wider means stretching, right? So this stretching is happening at x or y. Wider, you know what is wide? What is width? This is width and this is length. Yani width is actually x, length is y. She is saying wider and she is playing with x. يبقى x is going to be changed, not y. And we can say that for x and y will remain as it is. Now I need to find the scale factor of x. She is telling you that she's going to make this 50% wider. You remember in the exponential form when we were bringing the r, the common ratio, and I told you not only the common ratio. Remember this rule? Let me put it as a very side note here. It doesn't have any connection to our work. Just I'm giving you the idea. When we used to have this formula, the growth formula, f of x is equal to a 1 plus r to the power of whatever x or t or whatever. You remember this? And I told you, when he tell you the percent of increase is whatever, to find the percent of increase, the number I'm going to multiply, I'm going to do 1 plus a percent of increase. Because if you just put the percent of increase, it's going to be actually less than 1, so you are decreasing. I have to add 1. Here is the same idea. The same idea is happening here. The common ratio here is 50%, which is actually 50 by 100, which is 0.5, right? So to put the number that I'm going to multiply, I'm going to use the 1 plus r thing. So 1 plus 0.5 is actually what? 1.5. So this is the growth rate, or the scale factor that we are going to be using. 1.5x. So x became 50% wider. If I just add 0.5 يا بنات, if I just put 0.5x, if I just write x and y, became 0.5x and y. 0.5 is less than or greater than 1. It's less than 1. Less than 1, so this is stretch. This is shrink. That's why this is wrong. I have to add 1 first to make sure that it is the same size in addition to the new size. That's why it is 1.5x. Okay, so we wrote the new rule. After this, you are required to graph the image. So of course, to graph the image, what should I do? I should extract the points of the old image and then draw the new image. How many points we have here? This is a I don't know, it's a polygon maybe or something, and we have a lot of points. Let's extract them. We have A, we have B, we have C, we have D, we have E, we have F. It's 6 points. This is hexagonal. Okay, now let's find point A. Point A is 0 and 1, 2, 3, 4, 0 and 4. Yes, it's a 0 and 4. And then point B is 2 and 3. Point C is 2 and negative 3. Point D is 0 and negative 4. Point E is negative 2 and negative 3. Finally, point F is negative 2 and 3. And then you are going to apply this rule for it. You are going to multiply x only by 1.5. And y will be as it is. So 4 as it is, and 0 multiply anything is 0. So A prime will remain as it is. What about B prime? 2 multiply 1.5 is 3. And 3 as it is. This is B prime. For C prime, it became 3 and negative 3. Again, y as it is, and 2 multiplied by 1.5. This is C prime. For D prime, it's going to be 0 and negative 4. And then for E prime, it's going to be negative 3 and negative 3. And then the last point is going to be negative 3 and 3. This is D prime. This is E prime, and this is F prime. And then I have to take all of these points, which is belonging to the image, and then graph them to have this final image. As you can see, really, it became wider, right? Okay. And then we still have the last question that we are going to do, which is question 11. The last one today. Question 11. In question 11, you were required to use the 2 points H, which is negative 4 and 1, K, which is 4 and 1. And then for question A, describe the segment HK and find its length. To understand this question, I'm just going to graph for myself a very, very small coordinate plane just by myself and try to graph the 4 points, the 2 points, and see what's happening. 1 2 3 4 1 2 3 4. You don't need a real sketch, a real graph paper for this. Just you are trying to understand the shape of the line. So I have negative 4 and 1 as h, and we have 4 and 1 as k. If I draw this segment, because he is telling me the segment, drawing this segment, this is a what? Describe segment, yani just tell him what is the shape of the segment that you have. This is a what? This is a horizontal line. But this is the description. This is actually a horizontal line, which can be understood by the points right away. The x are changing, but y is the same. Yani we can say that here y is equal to 1. Y equal to number, this is a horizontal line. So it's a horizontal line. How many, what is the length here? The length, we don't need to use the distance formula here. We can just count points because this is a horizontal line. How many hops we have from h till k? 1, 2, 3, 4, 5, 6, 7, 8, which is actually 4 plus 4, which is a 8. So 8 points, or 8 whatever, 8 points, 8, just 8. Question B. Describe the image of segment HK under the transformation this, and he gave you these transformation that you need to apply. Okay, I'm going to put the rule that I need to apply. X and Y is going to be negative Y and X, and then put the 2 points we have. We have H as negative 4 and 1. It will become what? I have to, X will remain as it is in here, so this is going to be a negative 4, and the Y is going to be flipped here and flip its sign, so it's going to be a negative 1. What about K? K is 4 and 1. Okay, let's apply this for it. Again, I'm going to flip. I'm going to put the X in here, so 4 will be in here. And then what about 1? I should put the Y in the place of X, but flip its sign. Since it's positive, it's going to be a negative 1. And then I have to graph this again because he is telling me describe the line again. Well, let's graph it. The first point is negative 1 and 4. This is H. We can say it's H prime. And then negative 1 and 4. Negative 1, sorry, by the way, the first point was negative 1 and negative 4. It's down here. So this is H prime, and the one up here is K prime. If we connect this line together, what do we have? What is the name of this line? This is a what? This is a, yes, vertical line. Very good. This is a vertical line. Excellent. Okay, what else? This is question B. Let's go to question C. Describe the image of the segment HK under the transformation, and we gave us a new transformation. X and Y became 2x and Y. Yes, became 2x and Y. Take care. We are doing dilation here. Okay, I have H as negative 4 and 1. We have K as 4 and 1. Let's apply the transformation. Y as it is, and then I have to multiply this by 2, so it's a negative 8. Here I have to multiply by 2, it's a 8 and 1. And then let's graph the new line. Let's graph the new line. Here, for example, it's going to be an 8, and here, for example, it's going to be a negative 8, and this is 1, and this is 1. So the first point is negative 8 and 1. This is H prime. And here it's a 8 and 1. So this is K prime. And then if we graph this, again it's a what? Again it's a horizontal line. Again it's a horizontal line, right? But is it the same size as the original one? The original one here, you remember how many points it was? It was 4 points. Here, how many points is it? It's 8 plus 8, so it became a 16 point. Is it the same size? It's not the same size. We can write here that this is a horizontal line with 16 points length. In question D, he is telling you describe the two or compare the two transformation. We had how many transformation? We had two transformation in B and C. In B, when he did this from here, he did it like this. Is it a rigid or non-rigid motion? Remember, rigid and non-rigid is not about shape, it's only about size. How many points is this? This is 8. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8. Is it the same size? It's the same size. So actually, this is a rigid motion. But is this a rigid motion? This is non-rigid motion. Although it is the same shape, this is a horizontal and this is horizontal, but did it keep the size as it is? It didn't. And I can tell him that x and y became negative y and x. This is a rigid motion because it preserves length. But for the other one, x and y, which became 2x and y, this is actually a non-rigid motion. Okay? Okay, thank you very, very much for our work today. What you have to do today as a performance indicator, as classwork or homework or whatever, it's going to be inside the Class Dojo post. Thank you very, very much.